Hello and welcome back to another episode of Math with Sohn. Today we are going to be taking the greatest common factor out for factoring. So let's say we have something like 3x squared minus 12x plus 9. Now for a lot of us, we can realize that all three of these numbers can be divided by 3. And if you can do that, then that is what you were supposed to do. That is what you need to do. You can divide a 3, and by dividing by 3, you put it on the outside of the parentheses. And then you divide each one of these by 3. So 3 divided by 3 is 1. You don't need to write the 1, but you do need to write the x squared. 12 divided by 3 is 4x, because there was a 12x there. And it was negative, so it's a negative 4. And then 9 divided by 3 is 3. And sometimes this is as far as you have to go, but other times you can factor further. So I'm going to pause on this one because this one can actually go a little bit further, but that depends on what class you're in. If you're in Algebra 2, you would have to go further. If you're in Algebra 1, you might not have to go that far yet. So another scenario you could have is, let's say we have like 12x squared plus 6x. Here, they both can be divided by 6. This 12 doesn't have to be the number you divide by. They both can still divide by 6. But not only that, they both have an x. If all of the things or terms have an x, then you have to factor that out with the 6 that they can both divide by. And 12 divided by 6 is 2. And if you take away an x, you'd have a 2x. And 6 divided by 6 is 1, and if you take away an x, you're just left with the 1. And this would be our final answer. I'm going to be coming back to this one at the end of the video, so stay tuned to that if you are interested in factoring that further, because it will end up being something like this at the very end. All right, so I'm coming back to that one. Coming back to this one. This one can go further, but a lot of the people, the main point of this video is to not go further. Here, this one's done. So let's say we had something like this, where it's 3x to the 4th plus 2x squared minus 7x. On this one, they all don't divide by 2 or 3 or 7, but they all still contain an x. If they all contain an x, or it could be any letter for that matter, you have to factor that out. That is still considered a factor. And then you just remove an x. If we started with 4, we're down to 3. If we started with 2, we're down to 1. You don't need to write the 1 for your exponent. And if it only had 1 to begin with, it's going to disappear. And the idea is, if you distributed this x back out, it would end up being the exact same thing we had before. And we're done with that one as well. So let's say we have something a little more unique. Let's say we have 4x to the 6th minus 10x squared plus 8xa. That's a little weird. The xa at the end especially, right? But sometimes that happens where you have two different variables, and we're going to get into those on the next problem, but this one is a little ease into it. First off, I can't divide everything by 4, nor by 8, or by 10, but I can realize these are all even, and I can divide them all by 2. Not only can I divide them all by 2, but I have an x in all three terms. And I'm even going to upgrade it. I'm going to make this one an x squared, because we haven't factored out an x squared yet. If they all have an x squared, at least you take the thing that they all have, the smallest thing they all have in common, out. And then we divide each one of these by 2. 4 divided by 2 is 2. Take away 2 x's. We're not dividing by 2 here. We're just taking away 2 x's, which means we'll still have an x to the 4th left over. 10 divided by 2 is negative 5. If I take away 2 x's, I don't have any x's left over, so it's just negative 5. And then 8 divided by 2 is 4. And if I take away the 2 x's, the x squared, so to speak, those are gone. But I do still have this a, left over because I didn't divide by a, it's still going to just hang out. And that will be our final answer. Okay? So let's do one more where we got some like crazy variables going on. Let's do 4x to the third y squared plus 8x to the fourth y to the third. And we'll even do another one. We'll do plus 12x squared y. So now we got two variables. First, think about the numbers. Everything can divide by 4. That's a guaranteed. I'm going to start with that on the outside. And then I'm going to look at my x's. I have a x to the third here, an x to the fourth there, and an x squared there. I can't take any more out than I have, and all the smallest I have is an x squared, so I can only remove an x squared. I can't take anything more. I have a y squared, I have a y to the third, and a y to the first. You don't have to have the 1 there to know it's a y to the first. If that is the smallest y, that's the most I could remove. And that's normal that the last thing in line is the most you can remove. It's not always the case, but it's normal because sometimes things go in descending order. So I'm going to divide 4 by 4, and I get 1. I don't need to write the 1, but I did that for you, just for you guys. X to the third, if I take away 2 of the exponents, I have an x to the first power. Y squared, if I take away 1 of the y's, I would have a y to the first power. So I was looking here, and then I was looking at my x squared and my y. 8 divided by 4 is 2. Take away 2 of my x's, I have an x squared. Take away 1 of these y's, I would have a y to the first power. And then I deal with my last bit. We got 12 divided by 4 is 3. And take away 2 x's, I got no x's. Take away 2 y's, I got y y's. It's just a 3. It's just a 3. That's all we could do. All right, as promised, going back to the original problem. This is not the original problem. Where'd it go? Oh, it is. There it is. Sorry. Original problem. This last bit is factorable. And this is factorable not with a greatest common factor, but looking for what multiplies to equal 3, but would add to the middle term, which is negative 4. So what numbers multiply to equal 3, but add to negative 4 when it's in this format where it's x squared, x, no x's? And the numbers that multiply to 3 are very limited. It's just 1 and 3. And conveniently, 1 and 3 can add in some way, shape, or form to negative 4, and they would both have to be negative for that to occur. So negative 1 times negative 3 multiplies to equal 3, and negative 1 and negative 3 add to equal negative 4. So that's like a bonus. That is true factoring right there, though. That's going to do it for this episode. Until next time, stay positive, and I will see y'all later. Bye, everybody.